Okay, Ling-Yi, to calculate the change in momentum, alright, so it's equals to final momentum minus initial momentum. Alright, but because this is a vector, you cannot perform a scalar addition, you have to perform a vector addition. Alright, so in this case, you identify what is your initial momentum. So your initial momentum is based on initial velocity. Your final momentum is based on your final velocity. So in other words, you perform a vector addition, which is final. So your final momentum is this direction, right? Then that will be your final momentum, which is a PF plus a negative of initial. So it's always easier to add a negative initial momentum. So your initial is pointing in this direction, so your negative will be pointing in the opposite direction, and therefore that will be your initial momentum. Alright, so since a change of momentum is final plus initial, this vector will represent your change of momentum. Right, so to calculate this value, so it depends on which method. So basically from this point onwards, it should be math. Right, so in this case, your momentum is equals to mu. Alright, so mu, the numerical value is mu. This is also equals to mu. Alright, but we do know that it is angle at 60 degrees. If you look at the orientation, this is 60 degrees and comes to here. So this will be 60 degree, and of course similarly this one when it comes to here. Alright, so comes to here, it will be also 60 degree, which is you can resolve. Okay, so in other words, this is also 60 degree. Right, so this will be also 60 degree. So you can resolve. So in other words, as long as you have the ability to calculate this magnitude, right? So you realize that this magnitude is actually, if you learn how to resolve this, so it's basically this vector and this. Alright, so this component is opposite, and therefore the magnitude of this orange length is equals to mu sine 60. The magnitude of the other length is also mu sine 60. So and therefore your delta p, the length, right, will be equals to mu sine 60 plus mu sine 60, which is equals to 2 mu sine 60 degree. Alright, so if you plug in the values of sine 60 degree, it will be root 3 over 2. Alright, there are many ways to solve this change of vector. One method is either you can find out the vertical component, or the other way is using cosine rule. So alternatively, just for the sake of learning, alright, so you know that the angle over here is 120 degrees. So you can actually perform cosine rule. Alright, so this one I leave it to you to use it.